Good evening, everyone. Welcome back to the NPTEL online certification course on the topic water and wastewater treatment. So, this is the last week lecture, that is week 12. And as you all know, the course instructor is Dr. Bhanu Prakash from IIT Roorkee, and I am one of the teaching assistant. My name is Akash Saha, and I am a PMRS scholar at the Department of Civil Engineering at IIT Madras. So, I am pursuing my PhD in environmental engineering. So let us quickly see the contents of week 12 lectures. So we started with the discussion of residual management, where we discussed about the various types, sources, and the properties of the residuals. And what do you mean by residual management system, and how do we compute the solids in that? Then we discussed uh, one by one about all the residual management systems. So we started with the sludge thickening, where we discussed about gravity thickening, belt thickening, and the dissolved air flotation, and what are their design criteria. Then we moved towards the stabilization of sludge, where we discussed various aerobic, anaerobic, okay, and autothermal aerobic digestion processes, and followed by uh, lime alkaline process or composting. And at the end, we discussed about the conditioning, dewatering, and the disposal of sludge, where we discuss various methods to do all these things. So basically, I have a few multiple choice questions and some subjective type of numericals. So we will discuss them one by one. Let's see the first question. It says that which of the following is a common sludge conditioning agent? So we have four options here: ferric chloride, sulfuric acid, sodium hydroxide, or all of the above. So here we want to do the conditioning of sludge, and three chemicals are given. So you have to identify which one is commonly used for sludge conditioning. Please think about it. I will discuss the answer in a short time. Yeah, so the first question says that which of the following is a common sludge conditioning agent? Okay, so we have four options here: ferric chloride, sulfuric acid, sodium hydroxide, or all of the above. What do you think will be the common sludge conditioning agent? Any idea regarding this? So basically, we use these conditioning agents to improve the dewatability, okay, or to improve the consolidation properties of the sludge. Okay, so we promote the formation of any kind of flocks, right? And by doing so, we increase the dewatability. So the correct answer here is ferric chloride. Okay, so ferric chloride is most commonly used as a chemical sludge conditioning agent, which acts as a coagulant, okay, to improve the dewatering and consolidation properties of the sludge by promoting flock formation and neutralizing the negative charges on the sludge particles. So that's what is written in the detailed answer also, right? So let's move on to the next problem. It's a short numerical. So it says that considering the following data from a primary settling tank. So we have a primary settling tank where the discharge that is coming into the system is 0.05 meter cube per second. The influent suspended solids is 280 milligram per liter. Okay, and the removal efficiency of these suspended solids is around 60%. And the sludge solids concentration is 5%. And the specific gravity of solids and the sludge is given. Okay, actually the density of the sludge is given, and then the volume of the sludge that is produced daily in meter cube per day is asked. So this is about a primary settling tank where the suspended solids are getting removed. Okay, so 60% of them are getting removed, and the specific gravity and density, everything is given. So you have to calculate what is the volume of the sludge produced. So please try it out. I'll wait for some time and then I will give the solution. Please take a screenshot of it, or you can note it down. I hope you have tried the problem. Let's see how to solve it. So this is question number 2, right? So first we'll see what is the discharge given. The discharge given Q is 0.05 meter cube per second. Okay, so for our convenience, we will convert it to meter cube per day. So it will be 0.05 into 24 hours a day into 60 into 60. So it will be in meter cube per day. Hi Amit, are you there? Are you able to hear me? Okay, okay, then you just follow the lecture, no problem. No need to reply. I will show you the question once. So this is the question. It says that consider the following data for a primary settling tank. Okay. The details are given, the discharge. So we are discussing week 12 now. Okay, so this is the final week, and on next week Tuesday we will have the extra class. Okay, so you just follow the class. I will be discussing. No, you don't have to unmute yourself. No problem. You can type everything in the chat box. Okay, so the discharge is 0.05 meter cube per second. The influent suspended solids is 280 milligram per liter. Okay, no problem. The removal efficiency is 60% and the solids concentration is 5%. The specific gravity is also given. So you have to calculate the volume of sludge that is being produced. Okay. So first we have the discharge. We will convert it to in meter cube per day for our convenience. So it will be 4320 meter cube per day. Now the influent suspended solids is around 280 milligram per liter, or we can say it as 280 gram per meter cube. Okay, so the suspended solids in kg per day will be equal to 4320 into 280 gram per day, or 1209600 gram per day. And if we convert this into kgs, we will get 1209.6 kg per day. Okay, so this much amount of suspended solids, okay, will be produced, will be coming into the system per day, okay, with the discharge. So let us calculate the mass of solids that are removed in the PST, in the primary sedimentation tank. Okay, so this much amount is coming into the system. So how much is getting removed? So we know the efficiency is 60%. So 60.6 into 1290.6. So we'll get it as around 725.76 kg per day. Okay, and we also know the sludge solids concentration, that is 5%, it is given in the question. So we can say that sludge would have 95% of water. So if 5% solids are there in the sludge, then definitely it will have 5%, 95% of water, that is PW, and 5% solids, that is PS. So now, we know that the total mass of the sludge is nothing but mass of solids plus mass of water. Okay, the total mass of sludge will be mass of solids plus mass of water. So if 100 kg of sludge is there, so that means 5 kg solids plus 95 kg water, because that is the ratio, 95 is to 95. So hence sludge produced with 725.76 kg solids. So what will be my sludge? So that will be equal to 100 by 5 into 725.76. So out of 100, 5 kg solids are there. So for 725.76 kg of solids, the amount of sludge produced will be 100 by 5 into 725.76. So it will be 141, 14515.2 kg of sludge per day. Okay, so once we got the mass of the sludge, we can calculate the volume of the sludge. So let's calculate the volume of the sludge. So volume of sludge produced per day will be equal to mass of sludge produced per day divided by density of sludge. Okay, so this is in kg per day, this is in kg per meter cube. So it will be 14515.2 kg per day divided by 1050 kg per meter cube. So we'll get it as 113.324 meter cube per day. Okay. So very simple. So what is the flow? First we will calculate how much of, okay, so mass of suspended solids, okay, that is in kg per day. We will calculate what is the mass. So this is the first task. Then we will calculate what is removed, mass removed by PSD. So that is also in kg per day. Then for this mass removed, we have to calculate the sludge produced in, again, in kg per day. So this is on based on solids concentration. So based on the concentration of solids, the sludge produced will be get. So once we get the sludge produced, we will calculate the volume. So these are the four things you have to take into consideration. So mass of the suspended solid will depend on Q into the concentration. Here it will depend on the what is the efficiency, then the solid's concentration, and then the volume. So this will depend on the density. Okay, so the same thing we have done. Though it looks like a very big problem, but it's not actually. I have explained everything in words, that's why it looks longer. Okay, first calculate the suspended solids, then how much is removed, then what is the solid concentration, so because of which what will be the sludge produced, and then the volume. So this is the volume. Okay. Okay, then look, let's move to the next problem. So the answer is 13.824 meter cube per day. We'll move to the next problem now. Consider an aeration tank of an activated sludge process. Okay. The solid contents by weight is 5%. The specific gravity of sludge content is 2.6. Density of water is 1000 kg per meter cube. The sludge is put in a sludge thickener from the aeration tank to reduce its volume. The density of the sludge removed from aeration tank is. So we have to find out the density of the sludge. What would be my density of the sludge? So here you have to note that the characteristics of the solids, like what is the concentration of the solids, is given. Okay, and the specific gravity and density is also given. So based on that, we have to find out the density of the sludge. So simple formula we have to apply based on the volume, mass, and density. We can find out. So just note that the solid content is by weight. So here the picture of mass will come. Just think about it, try it out by yourself, then we can discuss. I hope you have tried it. So let's see the solution now. So this is question number 3. So in any system, the volume will not change. Okay, the total volume will be equal to the water volume plus the solids volume, right? The volume will not change. So how can we write volume? We can write volume as weight per density. We can write volume as weight per density. So what is this weight? This is nothing but the total weight by total density, or the density of sludge, because total thing is the sludge, is equal to water weight by water density. And also we can write solids weight by solids density. Okay. So what is the total weight? Let's assume if for 100%. So let's assume that the total weight was 100 kg. So we can write 100, right? What is the total density? Density that we have to find out because we want to find out the density of the sludge. So that is the total density. So let it be X. What is the water weight? It said that 5% by weight is the solids. So out of 100 kg weight, we can have 5 kg of water. And what is the water density? Water density we know. Sorry, it says 5% is solids. So that means 95 kg will be water. Okay, so since 5% of solids are there, so 95% will be water. So 95 kg will be water. So water density will be 1000. Plus solids we know it's 5. And what will be the solid density? Solid density will be specific gravity of the solid into the density of water. Okay, so we got an equation with one variable. Now we just have to solve it. So once you solve it, you will get x is equal to 1031.74 kg per. Okay, very simple. Just equate the volumes, the total volume. So this is for the sludge. So total volume will be equal to water volume plus solids volume. Now volume we can write in terms of weight by density. So total weight by total density is equal to water weight by water density plus solids weight by solid density. Now we consider that it's 100 kg of sludge is there. So out of 100 kg, 5% or 5 kg is my solids, 95 kg is my water. So we'll just equate it and we will get the answer. Okay. I think it's better if we solve all the numericals in one go. So let's finish it off and then maybe we can discuss some of the uh, multiple choice. Yeah. So this is another question. Okay, so though it looks very big, but it's actually a very small problem. Don't worry about it. So it says that a wastewater treatment plant consists of a primary treatment unit followed by an activated slash secondary system. Okay, so the primary and secondary sludges are mixed, thickened in a gravity thickener, and then sent to further treatment. And the schematic is shown. So you can see the influent is coming first to the primary clarifier, and then moving on to the secondary treatment, that is the aerator, and then the secondary clarifier. And you can see there are sludge lines, that is the dotted line, and which is being collected into the thickener. Okay. So now the characteristics is given. What is the characteristics of wastewater and the treatment plant? So wastewater having the influent suspended solids as 200 milligram per liter, and influent BOD is 225 milligram per liter, and effluent suspended solids is around 20 milligram per liter, and flow is 19,000 meter cube per day. Then for the treatment plant, the primary clarifier will remove 58% of the suspended solids. The BOD removal efficiency is around 32. The F by M ratio is 0.25 per day, and the biomass conversion factor is 0.35. So all the things are given. So we just have to find out what is the total mass of solids, that is the primary plus secondary is being generated in kg per day. Okay, so we just have to find out the total mass of solids. So there will be a solid that is coming out from the primary clarifier, and then there will be some part of solids which will be coming out from the secondary clarifier. So we have to just find both of them and then give the summation. Okay, you can go through the question once again and think about it, then I will discuss the solution. Okay, so let's discuss the answer. So let's find out the mass of the primary solids first. Okay, and then we will move forward. So mass of primary solids. So what it would be that is being removed from the system. So first is the removal efficiency into the influent suspended solids into the discharge. Okay, so that is 0.58 into 200 into 19,000. So that would be around 2204 kg per day. Okay, so this is the amount of primary solids. So now let's see what about the BOD that is being removed. So BOD removed in the clarifier, or I should say the primary clarifier, is around 32% of influent. So that would be 0.32 into 225. So around 72 milligram per liter is removed. So why this is important? Because suppose this is my primary clarifier, 225 milligram per BOD is coming, out of which 72 is removed from the system. So how much will go to the aerator? It will be only 225 minus 72. So that is 153 milligram per liter. Okay. Now let us see what is the BOD removed in secondary system. Because out of this now 153, some part will remove in the secondary system. So that is the the amount that is coming into the system minus what is my effluent BOD. So what is that? 153 minus 20. So around 133 milligram per liter is removed. So what is happening here is my secondary system. So from here 20 milligram per liter is going out. So what will be left? So it will be 150 minus 20, 133 milligram per liter. Okay. So now if 133 milligram per liter, or I can write it as 133 by 1000 kg per meter cube, or 0.133 kg per meter cube. So why this 133 milligram per liter is important? Because this will change in, this will be the sludge that is coming out from the secondary treatment. See, the sludge that is coming out from the primary, we know this is the amount kg per day. But how to get the sludge that is coming from the secondary? So this will help us to find, because this much BOD will be converted. So mass of secondary solids will be equal to my biomass conversion factor into BOD removed into Q. Okay, so that is 0.35 into 0.133 into 19,000. So it will be equal to 884 kg per day. So the total solids will be my primary solids plus the secondary solids. So 22404 plus 884. So we got it as 3088 kg per day. I hope you understood, because so I'll discuss it once again. So what is happening is, in the primary clarifier we are being given that how much of the suspended solids is getting removed as it is. So that is 0.58 or 58%. So we got the primary solid, that is very easy. Now for the secondary thing, the BOD will be converted into the suspended solids or the biomass. Okay, this BOD will be getting converted. So that's why it's very important that how much of the BOD is getting converted. So for that, we have to know that some part of the BOD will be first removed in the primary clarifier. So that we have to remove from the total. And then some part will be going as effluent. So whatever is the leftover part from the BOD that is going nowhere has to be treated. Okay, is going to change, uh, is getting treated, and it is going to change as biomass. So we found out that amount of BOD, and then we calculate the mass by using the biomass conversion factor. So per gram of BOD removed, 0.35 is getting changed into uh, suspended solids. So that's why that conversion factor is coming into the picture. Okay, I hope this is clear to all of you. Okay, we'll move to the next problem. So the answer is 3088 kg per day. Okay, the next problem. The thickened sludge from a sludge thickener is to be digested anaerobically in a standard rate digester. Volume of thickened sludge per day is 77.2 meter cube per day. That is entering into the digester. Total mass of solids in the thickened sludge is equal to 3088 kg per day. Sludge is known to be about 70% organic and 30% inorganic in nature. Approximately 60% of the organic fraction is converted into liquids and gaseous end products after a 30 days period. The digested sludge has a solid content of 5% and must be stored for a period up to 90 days. Determine the digested sludge accumulation rate per day in meter cube per day in the digester. So it is talking about the things that are coming into the digester and how it is changing and what will be the accumulation rate at the end of the period. So always remember that in a digester only we assume that the organic fraction is getting converted, okay, into gas things. Whereas the inorganic uh, solids or the inorganic substances will remain as it is. It will not get digested, or it will not be getting removed from the system. Okay, so the 30% inorganic that is there uh, in the digester will remain as it is. Whereas out of the 70% organic that is there in the system, 60% of it will get removed, or it will get digested into liquids and gaseous end products. Okay, so that is the main thing that you have to take care of. So just go through the question once again, try to analyze it, and then we will discuss the answer. So let's discuss the answer now. So question number 12. So it is given that the sludge loading rate is around 77.2 meter cube per day. Total mass of solids is equal to 3088 kg per day. So that we found out from the last problem. So this is from the last problem. Okay, this is directly taken from the last problem. So now the organic solids. So what will be my organic solids? So 70% was organic. So zero point 0.7 into 3088 kg per day. So that will be equal to 2161.6 kg per day. And the inorganic solids, so that will be around zero point 0.3 into 3088 kg per day. So that is around 926.4 kg per day. So this part will remain as it is. There will be no change in that because these are inorganic solids. Now since 60% is digested, okay, so now the organic solids left. Will be equal to 0 0.4 into 2161.6. So that is 864.64 kg per day. So out of the 2161 kg per day, only 60% is getting digested. So left will be only 40%. Right? So now the total mass of solids in digester will be equal to 926.4 plus 864.4. 864.64. Okay, so it will be around 1791.04 kg per. But that is not the final answer. We have to find out the sludge accumulation rate. So my sludge accumulation rate will be around 1791.04 divided by 1000 into 5% was the solid, so 0.05. So that is 35.82 meter cube per day. So first we calculate how much of the solids will be there in the digester, and from that we got the sludge. So again the percentage of solids will come into the picture, that is the 5%. Okay. So there are many extra informations given in the problem, so we have to be careful. So first, see what is the total mass of solids, out of which how much is organic and how much is inorganic. Inorganic will remain as it is. There will be no change. No change. Okay, but organics will be digested for 60% or whatever is given in the question. So find out what is left. Once what is left is found out, add both the left out parts, that is the inorganic part and the organic leftover part, calculate, then with the help of the solid content find out the sludge accumulation rate. Okay, I hope this is clear to all of you. Let's see one more problem. So it says that the next problem says that consider the following data from a primary settling tank. So the discharge is 0.04 meter cube per second. Influent suspended solids are around 260 milligram per liter. The removal efficiency with respect to the suspended solids is around 60%. Sludge solids concentration is 6, specific gravity 2.65, specific gravity of sludge or the density of sludge is also given. So you have to find out what is the volume of sludge produced per meter cube per day. So similar problem we have done, I think, before. Yeah. So maybe you can try it out again and then I will discuss the answer. So please try to solve this. Okay, so let's quickly see the solution because similar problem was discussed before. So question number 13. So first Q that is given 0.04 meter cube per second. So in meter cube per day, it will be 3456 meter cube per day. Okay, so now the suspended solids we will calculate in kg per day. So that will be Q into the suspended solids that is coming. So it is around 3456 meter cube per day into 260 gram per meter cube or milligram per liter. So that is around 898560 gram per day or 898.56 kg per day. Now removal efficiency is around 60%. So solids removed in PST will be around zero point 0.6 into 898.56. That is around 5939.136 kg per day. I'm going fast because the same problem was discussed in the second problem, I think. So just I'm giving you the solution. So in the sludge, it is given that 6% solids. So that means 94% water is there. Okay. So sludge produced with 539.136 kg per day, solids will be 100 by 6 into 539.136. So that will be equal to 8985.6 kg of sludge per day. Okay, so this much sludge will be produced. So once this is known, so the volume of sludge produced per day would be equal to 8985.6 divided by 1039. So this is in kg per day, this is in kg per meter cube. So 8.64 meter cube per day. Okay, very simple. So this is the final answer. You can note it down or take a screenshot, then I'll move. Right? Okay, another similar problem we will do, but yeah, a minute. Yeah. So this type of problem also we have done. So please try it out by yourself. Consider an aeration tank with activated sludge process. Solids content is 4%, specific gravity is 2.6, density is 1000. Okay, the density of the sludge removed. So simply I will just tell you the solution. So, so we know the total weight by density is equal to the water weight by water density plus the solid weight by solid density. Okay, in one line you can just write it like this. So volume, I'm just equating the volume. So if you solve this, you will get X as 1025.23 kg per meter cube. Okay, it's a one line question. Okay, so now let's see some more problems. Okay, based on similar lines, but the way it is asked is different. So it says that a batch of 4500 kg raw wet sludge with 98.5% water content, weight by weight, is processed, and the thickened sludge produced is 1100 kg. So estimate the approximate water content of the thickened sludge in percentage. So we have four options here. So please try to solve it and then we will discuss the answer. Okay, I'll wait for some time. Okay, so let's discuss the answer. So question number 30. So let us find out what is the, because to find out the water content, we should know what is the solid content first. Okay. So solids content in the 4500 kg wet sludge is equal to 1.5%. Okay. So 67.5 kg. Okay. So now solid content will not change even after drying or dewatering, whatever. Solid content will remain as it is. So after reduction in water content, total dry solids will be same as before, that is 67.5 kg. Therefore, the percentage of solid content in thickened sludge, in the thickened sludge, will be, how we will find out? So what is the total? That is 1100 will be equal to 100 by x, because we don't know the percentage, into 67.5 kg. So this is the density, this is the amount of sludge total we know, 1100. Okay, 1100 kg. So that is being equated to the amount of sludge that it would produce if 67.5 kg is solids. Okay, and we don't know the percentage. So from here we can calculate x. So my x will be equal to 6.136 percentage. So once we get the percentage of solids, we can get the water content. So therefore, water content of thickened sludge will be equal to 100 minus 6.136 is equal to 93.86 percentage, or 94 percentage. So this is the answer. Okay, just make a note of it. Right. So okay, then let's move ahead. One more numerical. So 94% is the correct answer. The same thing is being given here. Next problem. Thickened sludge received from secondary treatment with a total volume of 60 meter cube per day and a total mass of 2750 kg per day. It digested in a standard aerobic digester. The sludge is 75% organic and 25% inorganic in nature. 70% of the organic fraction is converted to liquid and gaseous end products after digestion. So estimate the approximate mass remaining after digestion. Okay, you have to find out the mass that is remaining after digestion. So how we will solve the problem? Okay, so everything information is given to you. So let's see. So what is the total inorganic fraction? Because that will remain as it is. So that is around 25%. So 25 into 2750 by 100. So 687.5 kg per day. Then total organic fraction after digestion. So we will directly calculate after digestion how much will be there. Okay, so it will be 0.3 into 0.75. So after digestion 30% remains, and of the total 75% is the organic. So zero point 0.3 into 0.75 into 2750. So that is equal to around 618.75 kg per day. So this is the amount that is left over after digestion, and this is the amount of organics in the system, 75%. Okay. So total mass of solids after digestion is equal to 618.75 plus 687.5. So this will be equal to 130625 kg per T. Okay. So the total mass of solids after digestion will be 618.75 plus 687.5. That is the inorganic fraction and the organic fraction left after digestion. So if we add both of them, we will get the answer. Okay. One more numerical we have. So yeah, this was the question. Now it is related to the previous question. It says that in question number 31, if the density of the digested sludge is 1010 kg per meter cube and the solid content is 5%, the digested sludge accumulation rate is. So what is the digested sludge amount? Okay. So we got around 1360.25 kg per meter cube of sludge. So if we have the solid content and the density, we can calculate the digested sludge accumulation rate. So this will be nothing but the digested sludge accumulation rate will be equal to 1306.25 divided by 5% into 1010. Okay, this is the density, and the other one, this is the solids percentage, and this is the density. And this is in kg per day. So the answer will be 25.86 kg per meter cube, or we can say roughly equal to 26 kg per meter. Okay, so I think these many numericals were only there today. So after this, we'll have some yeah. We have some multiple choice questions, so let's solve. Okay, so we'll quickly discuss all these multiple choice questions. Uh, so first one says that select the options which can be used as a bulking agent in composting. So we have food waste, shredded paper or tires, leaves, wood chips, or none of them. So what do you think will be used as a bulking agent in composting? Any idea? Just think about it. Just a minute. Right. So the correct answers are shredded papers, tires, okay, or leaves or wood chips. So these are generally used for the bulking. Okay. Next question, which of the following is likely to be not a major component in a primary sludge? Okay, is it inorganic sediments, dissolved organics, suspended organic matter, biomass produced at the biological treatment system? So which of them will not be a major component of the primary sludge? So what do you think? So basically in primary sludge, all the comparatively heavier particles, inorganic particles will get removed, okay, in the sludge. So yeah, it will have inorganic sediments definitely, and then some part of suspended organic matter which are heavier in size will be also a part of primary sludge, but biomass produced will generally will not a part of the primary sludge until unless it is returned to it. So that should not be the case, but please, but still some kind of biomass may be there, but dissolved organics will definitely not be a part of primary sludge. So the correct answer is dissolved organics. Okay, dissolved organics will be removed only in the aeration tank or somewhere after, like in the secondary sedimentation tank. Okay, so dissolved organics will not be removed or will not be a part in the primary sludge. So primary sludge mainly contains the inorganic solids and the coarser fraction of the organic solids. Next question, match the type of sludge produced with the appropriate treatment units. So we have waste activated sludge, sand and heavy solids, oils and fats, and we have three different tanks, either grit removal tank, secondary clarifier, and the skimming tanks. So you have to match them accordingly. So just think about it. So if we see the waste activated sludge, okay, or after the secondary treatment, that sludge will only be removed by the secondary clarifier. Okay, sand and heavy solids, being inorganic in nature, will be removed directly by the grit removal tanks, and oil and fats, which will be floating on the top, generally will be removed by the skimming tanks. Okay, so the correct answer is A. So for waste activator sludge, secondary clarifier, sand and heavy solids, grit removal tanks, and for oil and fats, it's the skimming tank. Okay. Next problem. The sludge component that does not directly reach the sludge processing unit. Okay, so which portion of the sludge will not go to the sludge processing unit? Like we have several processes like digestion, thickening, dewatering. So which part of the sludge component will not go there? Is it the return activated sludge, waste activated sludge, primary sludge, or none of the above? Okay. So here if we see, we have solved so many numerical problems also. So in each of the numericals, we were calculating what is the total amount of the sludge that requires the treatment or the processing. So there we used to add the primary solids as well as the secondary solids or the waste activated sludge. Okay, so primary sludge and waste activated sludge will definitely go to the sludge processing unit for further treatment and then disposal. But whereas the return activated sludge is the part of sludge that is being sent back to the aeration tank to retain the biomass in the system. Okay, we don't want our bacteria to just leave from the system without much use. So what we do is we return a part of this waste activated sludge because this is where the microorganisms are there. So we return a part of the waste activated sludge as the return activated sludge to the uh, aeration tank. Okay, so return activated sludge does not go to the sludge processing unit. Okay, so the correct answer is A. So a part of secondary sludge from the secondary clarifier is recycled to the aeration basin known as the return activated sludge, and the rest is sent to the sludge processing unit known as the waste activated sludge. Okay. Next, the volume reduction of sludge is typically achieved through reducing organic solids, reducing water content, reducing biomass, or reducing the organic matter. So the how do we do the volume reduction? So as you all know, volume reduction, either some kind of digestion should happen, which will remove the solids. Otherwise, inorganics will remain as it is. Okay, and yeah, but the major volume, as you all know, in sludge, almost 5 to 10% is only the solids. Rest of it is water. Okay, so the major chunk is water. So most of the volume reduction of the sludge is done by reducing the water content. Okay, because that is the major portion. The highest reduction in the volume of sludge is typically achieved by reducing the water content of the sludge. Okay, because more than 90% will be water. So if we can remove the water, a huge volume reduction will be there. Whereas the solids, not much. Okay, even after digestion, not much solids can be removed. Okay, let's move on to the next problem. Which of the following is not an objective of a sludge thickening process? Okay, so if we have a sludge thickening process, which is not our objective, to reduce the total volume, increase the solid content, reduce the water content, or increase the organic to inorganic matter ratio. Okay, so sludge thickening, we know we want to increase the solid content. That's why we are calling it as thickening. So increasing the solid content is a part of sludge thickening process. Also, in order to increase the solid content, we have to reduce the water content. Okay, we will reduce the water content and overall we will reduce the volume. But the organic to inorganic matter ratio, that will not increase. Okay, that is not the objective of the sludge thickening process. Okay, so the sludge thickening process reduces the total volume, increases the solid content, reduces the water content. However, increasing the organic to inorganic ratio in the sludge is not the primary objective of the process. Okay. Next, sludge conditioning can be obtained through iron salt addition, lime salt addition, hydrolysis, or any of the above. Okay, so here it's a very direct question. All of the above can be used for the conditioning of the sludge. Okay, so all these three things, like the iron salt addition, lime salt addition, hydrolysis, can be carried out for the sludge condition. Right? So all of this can be used. Next problem. Select the most appropriate option for statements A and B. So we have the statement A as the ratio of volatile to total solids indicates the organic fraction in the sludge solids. Statement B, the density of specific sludge sample is typically highest in the raw form and reduces with sludge processing stages. Okay. So first statement says that volatile to solids, total solids, indicates the organic fraction. So as you all know, the organic fraction is mostly the volatile in nature. Okay, the part of sludge that is volatile in nature, we represent it as the organic fraction. So definitely, if we have the ratio of the volatile to the total solids, we will know how much is the organic, because that can be easily removed by just heating or burning it off at a very high temperature. Whereas the Whereas the statement B says that the density will increase with the sludge processing unit. Okay. So as you know, the sludge processing unit processes will try to reduce the water content and increase the solid content. So once the solid content is increasing through the sludge processing stages, the density will increase. It will not decrease. Okay. So that means statement B is false. So the correct answer is C. A is true and B is false. Because as and when we are processing the sludge, we are trying to remove the water content, okay, and increase the solid content. So if the solid content will increase, the density will definitely increase for the sludge. Next, filling the blanks with the appropriate stage of the sludge handling sequence. So we are starting with thickening, then stabilization, then dash, hygienization, and then drying. So you have to fill in the blank with either restabilization, degeneration, dewatering, or hydrogenation. So we have thickened the sludge, then we have stabilized it. So now it's important to remove the water content. So we will dewater it. So hence the correct option is dewatering. Okay, so thickening, stabilization, dewatering, hygienization, and then drying. Okay. Okay, moving on to the next problem. Centrifuge, filter press, belt press are different types of mechanical sludge dewatering system, mechanical conditioning system, mechanical sludge hygienization system, or mechanical sludge digestion system. Okay, so the names are centrifuge, filter press, or belt press. So as the name suggests, you can simply say that these are a part of sludge processing unit which will try to remove the water content or will try to dewater it. Okay, by pressing like belt press or filter press or centrifuge, moving it fast. So it will try to separate the water from the sludge. Okay, so these are mainly sludge dewatering systems. They will try to separate out the water from the sludge because water content is the highest content in the sludge. So that's why we want to dewater it. Which of the following offers an option to use sludge for energy production? Okay, so which of these techniques can be used for energy production? Land disposal, aerobic composting, anaerobic digestion, or both A and C? So for energy production, we generally try to digest the sludge in such a way that biogas is produced primarily composed of methane and carbon dioxide. So this methane can be then converted into energy. Okay, so we convert or digest the organic fractions of the sludge into methane through a number of processes. It starts with hydrolysis, then acidogenesis, then acetogenesis, and then methanogenesis. So in the final stage of the methanogenesis, methane is getting formed, which will then be converted into energy. So the correct answer is anaerobic digestion. Okay. Whereas land disposal and aerobic composting are not the option for the energy production. Okay. Sludge hygienization is primarily the process of reducing weight and volume of sludge, dewatering of sludge, reducing the content of pathogenic bacteria to an acceptable level, or all of the above. Okay, so we are talking about sludge hygienization. So as you all know, most of the sludge is very rich in pathogens. A lot of microorganisms are there, and it's important that we have to remove this pathogenic bacteria. So that's why we do hygienization for hygiene purposes, obviously. So that's why sludge hygienization means reducing the content of pathogenic bacteria to an acceptable level. Okay, so before uh, disposing this sludge, it is very important to remove the pathogenic bacteria. So that process is known as sludge hygienization. Whereas the other part are to remove the to reduce the volume of sludge. Okay, reducing the weight and volume or dewater of sludge. So it will just reduce the volume of sludge. It will not remove the pathogenic bacteria. So municipal sewage sludge hygienization or disinfection, so it is also known as disinfection, is a process to reduce the content of pathogenic bacteria in the sludge below a certain level which is accepted by the competent authorities. Next problem. An apparent disadvantage of using a sludge drying bed is for dewatering is complicated process, more applicable for industrial sludge, high energy requirement or large land requirement. So here we are talking about dewatering. So in this, the water is being removed by drying beds. Okay, we will simply put it over a piece of land and we will let it dry. Okay, the water will evaporate. So what do you think is the problem? So so basically it's not a complicated process. We have to just simply lay the sludge over a piece of land. So it's not very complicated and it is not applicable for industrial sludge because it will carry a lot more toxic things. Whereas there is no energy requirement also. The only problem with this process is there is a huge land requirement because we have to dry it. So we have to have a very large piece of land for the drying beds. So the problem with sludge drying bed is its large land requirement. Okay. So this is the simplest method of dewatering and an inexpensive process. However, they have to have a large land footprint. Okay, then yeah, so that's all I think. So we have discussed all the numericals and the multiple choice questions. So these numericals I have already discussed with you. So you can, if you have not attended the live session, you can see this recorded lecture on YouTube. I will upload it soon. And yeah, once it's uploaded, you can go through the lecture. And so we will have the last session for this NPTEL problem solving session on water and wastewater treatment on 15th April. Okay, it's a Tuesday from 7 to 9 p.m. our usual time. So today's was an extra class. So instead of taking the extra class today, I shifted it to 15th April. So we will have the extra class on 15th April in our usual time from 7 to 9 p.m. on Tuesday. Okay, so if you don't have any more doubts, you can leave the session. So that's all from my side. And if you have any queries at a later point of time also, you can get back to me in the mail ID. Okay, so thank you. That's all from my side.